This obviously slab will be just be under most of the time for uh, liquid pressure or water pressure. Because of that, most of the time it will be subjected to the compressive force. Only one only time that will be subjected to the tension when it is subjected to the uplift. Okay, but otherwise, yes, it is most of the time it will be subjected to the compression. And concrete is a very good element for the compressive force. So if you are doing any design of rectangular tank, so you don't need to design anything special for base slab, because there are two things. Because when we fix the thickness of the base slab, that is more than wall. In our case, wall thickness was somewhere, I think, of 500, and we have considered additional 50 or additional 100 thickness for the base slab. Okay, because what happened now, that bending moment in the wall is get transferred to the base slab. Okay, so ideally what needs to be done, ideally same thickness, same reinforcement need for the base slab. Okay, so what we are doing, we are providing additional thickness to the base slab. Instead of 500, we are providing 550 or 600. So in terms of thickness, base slab, my slab thickness is a safe, if it whether it is shear force. Okay, and we are providing same wall reinforcement to the base slab finish. You don't need to do anything special for the base slab. Understand? So this way your design for the base slab is also done. Just single line, base slab thickness 600 with same reinforcement of the wall. That is, same reinforcement means that the bottom part, not the mid part, or not at the top of the slab or at the top of the wall. Okay, so this way we can just quickly take care of the base slab. So done. In detail, yes, I will explain you when we will do the analysis by using the software. But if you are going to use the PCA table, so there is no special things that can be possible for the base lab. But this is more than conservative or more than safe. So even though if you do some rigorous calculations for the base lab, so your provided result will be 200% safe. Understand? I will share my screen. Let me know once you can see. Is it visible?
Yes, sir.
Okay. So now today we will start with the circular tank. Okay.
सर सॉफ्टवेयर पर वो टैंक का अंडरग्राउंड टैंक करवा देते हैं प्रैक्टिस के लिए?
हाँ, लेकिन 1 बाय 1 जाएंगे.
तो वो सर वो हो गया ना, रेक्टेंगुलर अंडरग्राउंड हो गया तो वो करवाते हैं, फिर इसके बाद ये सर्कुलर टैंक लेते हैं.
इसके लिए एक ही सेशन लगेगा, तो मेरा मैनुअल कैलकुलेशन पूरा खत्म हो जाएगा. ठीक है.
सर एक चीज पूछना था कि आपने वो उस समय टोटल अपलिफ्ट प्रेशर निकाला था तो वो फेल हो चुका था, फिर वो आगे 1 मिनट सर.
वो फेल नहीं हुआ था, मैंने ऐसे रैंडमली फिगर डाले थे, नंबर्स डाले थे. सो यू हैव टू कैलकुलेट द सेल्फ वेट ऑफ द टैंक, and you have to calculate the uplift pressure and then compare. वो फेल नहीं हुआ था, मैंने ऐसे ही नंबर डाले थे उस समय.
ओके, क्योंकि सर वो अपलिफ्ट प्रेशर में अपने 7312 किलो न्यूटन एक्स लिखे हुए थे, तो मैं फिर वहाँ फेल लिखे थे, तो मैंने देखा, उसको मैं स्टडी कर रहा था तो मैं देखा, मैं फिर इस पर
नहीं, आप एक बार कैलकुलेट कीजिए सेल्फ वेट ऑफ द स्ट्रक्चर, यू जस्ट कैलकुलेट and as against you can compare what is the uplift force. So in that case, if your uplift force is more, then obviously it's failing. Okay, so again, in that case what you need to do, you need to increase the thickness such a way that the self weight can be sufficient to act against the uplift force.
ओके सर। सर तो ये हम लोग बीटेक में सर देख पढ़े थे जो उसमें तो ये पीसीए टेबल था नहीं।
नहीं, पीसीए टेबल मैंने भी पढ़ा, बीटेक में पढ़ा, एमटेक में भी नहीं था।
बीटेक में मेरे में नहीं था सर, क्योंकि मैंने नोट सारा मैं रखा हूँ।
नहीं, मेरे में भी नहीं था ना, मैं वही बोल रहा हूँ, मेरे में भी था, नहीं था।
मैंने उस पलट के देखा, बहुत डिफरेंस था दोनों में।
हाँ, तो मेरे पास भी नहीं था। जब मैंने काम करना शुरू किया कॉलेज में छोड़ के, तब मैंने ये मुझे मिला एक जगह से रेफरेंस। बीटेक में गया, एमटेक में भी नहीं था मेरे पास।
ओके सर।
ठीक है, तो
ओके।
क्विकली हम आज ये फिनिश करते हैं सर्कुलर टैंक, एंड आफ्टर दैट वी विल जस्ट गो विद ऑल द प्रोग्राम लाइक स्टैट प्रो। ठीक है, चलो, we will just check circular diameter, circular tank. Assume diameter of the tank, internal diameter, assume as a 13.2 meter. I'm just taking one example. Okay, height of the tank is, let's say, 4.1 meter. Operating height of the fluid 3.8 meter. Okay, and wall. So maybe you can use the thumb rule, but yes, currently I'm just assuming thickness of the wall as a 200 mm thick. बेस स्लैब मैं एज्यूम कर रहा हूँ 500 mm थिक। रूप स्लैब नहीं है, कैंटिलीवर मेरा टैंक है, दैट इज ओपन, एंड आई हैव द टो विड्थ फॉर द बेस स्लैब इज अ 500 mm. Okay, so now how to use the PCA table, but before that we will just finish the loading as usual. Okay, so first case, tank full, no soil backfilling. Test condition, tank full height is almost, ये इसका आ रहा है क्या, आप 3.7 करते हैं। ठीक है, इसको मैं थोड़ा चेंज किया मैंने, क्योंकि इट इज मच इजियर टू चेंज हियर रादर देन इन माय इन दिस फिगर। 7.5 है, ठीक है, इसको मैं 7.5 करता हूँ, कोई टेंशन नहीं। ओके, तो अभी फर्स्ट लोड केस, टेस्ट कंडीशन, case 1, tank full with no soil backfill. So assume test condition, tank full up to 3.75 meter. ये तो मैंने कॉपी पेस्ट हो गया इसलिए थोड़ा सा कंफ्यूजन हो रहा है, बट ठीक है। I need to change this because it is same thing from, maybe I will check. ठीक है, कोई बात नहीं। इसको मैं 80 रखता हूँ, जाने दो। तो फर्स्ट केस 1, टैंक फुल,
सर ये भी अंडरग्राउंड है सर्कुलर।
कंसिडर करो अंडरग्राउंड। अगर अबव ग्राउंड है तो क्या होगा, सॉइल भी नहीं होगी ना, पानी
यस
तो
सर।
रहेगा। अंडरग्राउंड हो ना हो, पानी तो रहेगा।
पानी रहे।
अगर अबव ग्राउंड है तो सॉइल नहीं रहेगा, तो थोड़ा सा और सिंपल हो जाएगा, इसलिए मैं थोड़ा सा डिफिकल्ट करने की कोशिश कर रहा हूँ, चलेगा ना।
कोई नहीं सर।
टैंक फुल, water pressure, what will be the water pressure for test condition, And someone tell me. I will just change this to 4.1 only. Now, tell me someone what will be the water pressure. For 4.1 meter of water height. कितना होगा water pressure? 41 होगा. 4.1 into 10, that is 41 kilonewton per meter. Triangular shape में. Soil load. Same thing 0.5 assume करो. Up to the ऊपर तक. Soil will be filled up to the top of the tank. 0.5 into 4.1 into 20 soil density. ये भी कितना आ रहा
41
है? उतना ही आ रहा है. Good. Surcharge, assuming 1 meter of soil. कितना आएगा? 0.5 into 1 into 20.
10
ये मोमेंट नहीं है. ठीक है. So this is our loading. Okay. Case 2, tank is empty. ठीक है. तो I will ask you some basic questions. This is my circular tank. This is the plan. Assume this is a plan. Water is subjected to from the inside. So what will be the things happen in wall? Water pressure है, act हो रहा है. यहाँ पे water is acting everywhere from inside. What will be happen with the wall? This is the plan view. I'm just standing just above the circular water tank. क्या होगा?
हुक
हाँ?
टेंशन हुक टेंशन
circumferential tension develop होगा सर
हुक
बॉल में.
टेंशन
Correct. Hoop tension, circumferential tension. Correct. What because of what happened? Because of this water pressure, what wall try to expand. Correct. Just like when we try to fill the air in any balloon. तो क्या होता है कि जो the surface is subjected to the tension, hoop tension, circumferential tension. That is absolutely correct. Okay. So for circular tank, in addition to the bending moment and shear force, we have to find out one more thing, that is a tension in the wall. Okay. So this is now for the water pressure. Now what happened? Because now soil is acting from all over the periphery of the wall from outside. So what will be happen now? So assume there is a no water, or let's say okay, water with water. Water ko chhod do. Don't consider water from inside. Just tank wall is subjected to the soil pressure from the external face. So now what happened?
Bending.
Bending, correct, okay. And
It will shrink, compressive.
correct. So because of soil pressure, what happened? Wall will try to get shrink. And because of that action, compression will be created in the wall. Correct. So these are the basic reactions or basic things happen with respect to the different types of pressure. So if wall is subjected to internal water pressure, because of that water, what happened? Tension will be generated in the wall. As against, if we consider the soil load from the outside face of the wall, because of that, compression will be developed in the wall. And since the compression, concrete is a very good in compression, you don't need to consider anything because of the soil pressure. Just need to consider bending moment if it is. Okay. So we know ये compression ठीक है, लेकिन yes, so I need to just take care for the tension, and you can straight away neglect the any action due to the soil load in terms of the compressive force. Okay. But we need to just confirm that compression should not be get more than the strength, compressive strength of the concrete. Suppose if you are using M25 concrete, what is the meaning of M25?
That is the compressive strength of concrete at 28 days.
Okay, that is the 25. What is the unit?
25
M20.
Newton per mm square or 25
Yes,
megapascal.
yes, correct. So you have to just check that the maximum compression should not be more than 25 kilonewton per mm square. So if it is less than that, you don't need to take, you don't need to check any additional checks. You don't need to provide any reinforcement, because oh, anyway, we never provide any reinforcement for compression. Concrete is itself take that. Correct. We always provide the reinforcement for the tension, for sagging or for hogging. Correct. Understand?
Yes, sir.
Okay. Okay. So what what are the items that we need to find out? The bending moment, as always, shear force. My mouse is not moving properly. And tension. So in a circular tank, we need to find out three things for analysis. Okay, so that will be our ultimate aim. Got it? Okay, now again I'm going back to the PCA table. Okay, so similar to the rectangular tank, so we have a PCA table, Portland Cement Association table for circular tanks also. And the limitation of this PCA tables is it is consider only cast in situ. It is not, if you have a pre-stress or post-tensioning tank, so you cannot use. Same with the rectangular also. Okay. So you cannot use for pre-tensioning or post-tensioning things for the circular tanks. Okay. Anyway, so same thing. There are many things to just you need to go through that. But yes, you can go. But just for our purpose, understanding purpose, I will just directly go to the again the index page, similar to that load cases. So you can find this some, maybe you can call as an index or anything. So you will get different tables like from A1 to A20, and the support systems are defined. Okay, fixed base, top free, for triangular load, means for water load. If you want to find out the ring tension, yes, you can go to the A2. Fixed base top free triangular load. If you want to find out the moment, you can again stay with that same page A2. Now the things like fixed base top free rectangular load. Rectangular means now it is for the surcharge type load. Okay. So for that, yes, because of that also there will be some additional tension. So maybe you need to go to that A3. So similarly, based on that, and you can see some changes happens with reference to the support system from fixed base to hinge base, from hinge base to top free. So these are the some changing some parameters for the supports. Okay. And shear force, how to calculate? So table number A12 gives the shear force of the cylindrical wall. If you go to the page number A9, so by using this A12, we can easily find out the shear force in the wall. Okay, at the base, because shear force is always maximum where shear force is always maximum.
Fixity.
Fixity means support. Okay.
Yes.
Okay, that's why it is mentioned that shear force at base, because
Yes.
our wall is fixed at base to the base slab. So obviously our shear force will be maximum at base. If you just go away from that base slab, what happens? The shear force will be get reduced.
Reduced.
Okay.
Sir, here the fixed base and hinge base,
Hmm.
the difference would be the detailing portion only, na?
Yes, only the detailing portion. Correct.
Yes.
Because of water pressure is same for fixed base and hinge base. So अगर हमने पानी भरा तो वो फिक्स बेस के लिए पानी ज्यादा नहीं होगा और हिंज के लिए पानी कम नहीं होगा. करेक्ट. So at both cases, water pressure or soil pressure will be same, even though the bending moment will be also same. But what happen, based on that support condition, your pattern of the bending will be get changed, and based on that, your that bending moment numbers will be also get changed. Correct.
Yes.
अगर मान लो कि 100 किलोन्यूटन मीटर मोमेंट आ रही है for hinge base, maybe at center of the span, उसको हमने चेंज किया फिक्स बेस पे, तो क्या होगा कि सेंटर पे वो 90 की जगह पे होगी 55. जस्ट मैंने एक्सप्लेन कर रहा हूँ, जस्ट गिविंग अ रैंडम एग्जांपल. सो इफ वी चेंज फ्रॉम हिंज बेस टू फिक्स बेस, सो व्हाट हैपन दैट, मैंने 100 बोला था या 90 बोला था? 100. 100. तो वो 100 किलो न्यूटन की मोमेंट क्या होगी, फ्रॉम 100 टू इट विल बी समवेयर reduced to 50 at somewhere midpoint, and again remaining 50 will be generated to the base of the slab. So if you just make it additional, so it will be remain same, because ultimately क्यों आ रहा है? Because of water pressure or because of soil pressure. वो तो कुछ हम नहीं कम कर रहे. Correct.
Yes.
So location and magnitude will be get changed based on the support system.
Yes, sir. According to that, we will going to provide the steel.
Yes, provide the steel, provide the detailing. Detailing is a very, very important.
Yes, sir.
So
Okay.
how to find
Yes.
out this one, sir, which is hinge and which is fixed in the problems?
I'm not able to hear you properly.
How to this one, sir? Find out, sir, which is hinged and which is fixed in this one, sir. In reality, sir.
Okay, so you are engineer.
Yes,
Okay,
sir.
so you want to design the tank.
Yes, sir.
So what will be the workflow? So you will design first, correct?
Yes, sir.
So it's your choice, it's your assumptions whether you are going to provide the fixed base or hinge base, correct?
Okay.
So if you assume hinge or if you assume pin, so accordingly you have to prepare the drawing detailing part, and then it will be transferred to the site,
Okay, sir.
correct? So it's only you to design, to assume, to implement, and to create the drawing and to pass it to the contractor. So it's your choice.
Okay.
Okay. So,
Sir,
hmm,
sir, in bridge design, we generally keep one support as a hinge because of expansion and contraction, right?
correct.
So that logic can be applied for tank also.
No, because what happened for bridge, there are some moving loads also, correct?
Yes,
So that's why that is also the one reason, because there is some braking loads also, sudden break.
yes,
It is day to day life that loads are coming. That's why we consider one fix and one roller or some kind of that. And for
yes,
water tank also, definitely yes, we need to provide some expansion and contraction joint, but there is some limit also, like 150 means how feet. So suppose your concrete casting of the concrete is more than 50 meter, so then in
okay,
between that you have to provide the expansion or contraction joint.
okay, sir.
And and second thing, so your bridge is not a water retaining structure,
Yes, right.
and as against you are casting a tank, so if you provide more joint you are more susceptible to the leakage. अगर हमने
Yes,
जितने जॉइंट दे रहे तो लीकेज का चांस बढ़ेगा, करेक्ट?
yes, sir.
So we have to take care of that. अगर joints, we will try to minimize the number of the joints.
Okay,
But yes, so if it is more than length of the wall or length of the base slab is more than 50 meter, definitely we have to provide the expansion joint. But that joint needs to be designed such a way that from that joint your water will not get leakage.
okay,
Okay. So
yes, sir.
so in industry there are some different types of joints also coming with the water stop. अगर हमने वहां पे water stop डाला तो it will take care of prevention, like as acting as a prevention or something like that, can take, or it can help us to stop the leakage problem. वाटर स्टॉप कभी देखा है?
नहीं sir.
वाटर स्टॉप में भी गूगल करके देखिए वाटर स्टॉप.
Sir,
Okay, sir.
is it the water bars which we place during the concreting works?
वाटर बार can you hear me?
Yes, sir.
By mistake I just click on the close the button.
Yes, sir.
That's why I get disconnected. Yes. So no, water stop is different thing. Maybe I will just try to open this. I will try to check. Can you see this? So these are some like PVC material which is fixed. If you can see this, so this will act as a.
Screen is not visible.
Oh, sorry. now.
Yes, sir.
Can you see this?
Yes, sir. Yes.
So this is the water stop, some kind of PVC plastic type material. So now this is the joint. So we will cast again the another portion of the slab against this portion. So what happened, because of this, water will not directly get passed to the ground. And same thing with this also. So if you can see this, so there is a vertical water stop is provided. Okay. So because of this, water will not directly come out from the wall base. You can see this. So it is typically used everywhere for the water construction of the water. Clear?
Yes, sir. Yes.
And it in detailing part also we need to show this, provide. Yeah, we have to provide the water stop. Suppose
Okay.
if this is my wall cross section, this is my slab. So now what happened? So this is a water. So now water, because of construction will be like this. So you will first cast this base slab and then you will cast the vertical wall. So what happened? There will be a joint here, this joint. So water may be get passed through this joint, correct? If you don't provide any water stop. So what happened? So if you provide water stop here, this PVC sheet here, so then what happened? What there will not be any road or any space to seepage out. So that's why
Yes, sir.
we will provide water
Yes.
stop here. And
Yes, sir.
generally we have Hmm?
Because we cause first the raft slab and then we go with the vertical walls. So
correct,
there is
correct,
a high chance there will be leakage at the joint portion.
correct, correct. So
So,
to
so
avoid
during so during the execution of the walls,
base
after
slab,
the yes, yes, after the reinforcements works, we put this water stops.
yes. So
When
during
it, when
casting of the
it,
base slab, you have to
yes,
basically you have to provide the water stop like this. Okay. So
yes,
some portion will be get exposed and some portion will be get embedded
embedded
into
into the
the
concrete.
base slab.
Yes,
Then you have to fix the shutter and pour the concrete. So now this wall, this joint will be
yes,
a
it
great
will
help.
be.
Yes. And this, if you just want to draw the 3D, so this will be some small sheet of the some corrugations, and
Yes,
that
yes,
is this one.
yes, yes, sir.
Okay.
Yes, sir. Yes, perfect.
I will close this now. So now I'm going back to the PCA table. So yes. So now yes. So as usual. So there are different um, support system are mentioned based on the triangular or rectangular load. So now you are well aware what is the triangular load and what is the rectangular load. Okay. So now so we have the cantilever water tank which is fixed at the base and free at the top. So I will go to this A1 table, page A1, A2. Yes. So just read this fixed base, free top, triangular load. Yes. So we want to this. So you can see this. This is a cut section of the water tank. That's why you can see these two walls. Okay. Water is and internal load can be shown as like this. H is the height of the tank. R is the radius. D means diameter, and small t represent thickness of the tank, and WH is the loading. Okay, clear all the terminologies.
Yes,
Very
sir.
simple and very easy, self-explanatory. Okay, now how to find out the tension? Again, so if you see there are some different tables are given. So if you go, is it visible?
Yes, sir.
Okay, so like for rectangular tank, what we find out? We find out the aspect ratio, that is B by A, correct? So on similar basis, we have to find out the aspect ratio for circular tank also. How to find out that aspect ratio? That is h square by dt. What is h? H is the height of the tank, d means diameter, and t means thickness. Okay, so in our case, what will be our aspect ratio? dt h square by dt. Can you calculate? Where I want to format. No, somewhere I will. This is h square. I just try to find where I can super format. Yes, yes. Now it's good. Tell me, you have everything in front of you. So what will be the aspect ratio? I will also try to calculate h square.
So sir, T is not mentioned.
T is given here.
Oh, thickness of all two. Okay, sir.
Got it? What is the aspect ratio?
So 6.36.
6.36.
36.
Correct. Yes. So it comes as a 6.36. So can we make it as a round figure? Yes. So let's go to the PCA table and just check. So it is 6 and it is 8. So maybe we will go with the 8. Okay. So say 8. Hmm. Okay.
Sir.
So I'm coming back to this. Yeah. So now in our case, our aspect ratio is 8. Okay. Now we have to find out the coefficients at any point, like similar same thing. At 0, we will get some coefficient. At 0.1h means somewhere here, we will get some coefficient. 0.2, 0.3, 0.5, like mid height, 0.6, 0.7, 0.8, 0.9. So we will get some coefficients. Okay. So as last time also I mentioned, we always find out the maximum. So just don't go and see this. So just try to get it the maximum coefficient, because what is the formula for tension? Tension is equal to coefficient into WHR. WH means the
Load.
pressure, water pressure, and R means our
Radius.
radius of the tank. So for 8, what is the maximum coefficient that we are getting? It goes somewhere.
0.575.
0.11, 0.5. 575. So yes, so 0.575. So this is the maximum. And don't consider any negative, because a negative means we are getting compression. Okay.
Okay, sir.
So just consider always the maximum positive values, which is related to the tension. So 0.57, 0.575. So now calculate the tension. So what will be the tension? Coefficient into WHR. 0.575 into 41 into 13.2 divided by 2.
6.6.
What will be the answer?
155.59
Okay, so let's assume 156. What is the unit of tension?
kilonewton.
Kilonewton, correct. So this is
Sir,
a service
for
level.
that,
Hmm?
sir, in PCF table it is given by LB per feet something. T is
LB,
equal to,
yes. So LB for, because it's a American units. Okay.
okay,
So what is your unit? Coefficient
it is
for, what is unit for coefficient?
coefficient unit. There is
So it's
no
a
unit.
unitless. It's a
Yes.
unitless. Hmm. So now what is your WHR unit of for the water pressure?
It will come kilonewton, right?
Kilo,
Tension.
kilonewton, because we are considering for 1 meter strip.
Hmm.
Okay.
Right.
And
Hmm.
what is the unit of
Meter.
R?
Meter.
So what will be remaining? M will get cancelled to this one. Correct?
Yes.
M will get cancelled because this is on denominator. Correct?
Hmm.
So only remaining thing will be
Kilonewton.
kilonewton. And this PCA table, which is basically developed in the United States.
Okay.
So if you refer everything, so that's why you will find this LBS system, pounds and capes and those things. But the main beauty of these tables, those are the coefficientless. It's a unitless, sorry, not coefficient, unitless. So just you can provide your units and you will get the answers as per your units.
Okay, sir.
Okay. So now
Yes.
you will get the tension, and this is service level. So maybe you can just multiply with your load combination. Suppose for 1.24, 1.4, maybe you can just 156 into 1.4, 218.
So 1.4 क्यों दिया?
लोड कॉम्बिनेशन,
अच्छा.
मान लो मेरा लोड कॉम्बिनेशन 1.4 डी प्लस 1.4 रेफ फैक्टर है, तो इसलिए मैंने 1.4 लिया. ठीक है.
Okay, sir.
तो अब तक हमने क्या किया? टेंशन निकाला. अभी नेक्स्ट स्टेप, मोमेंट. Just go to the moment. Just before that, go to the index. So we are done with this. Now we need to find out the fixed space free top triangular moment. Moment हमको निकालना है. So we have to go this A2 on the same page. We will have this table. So we already find out the aspect ratio, that is 8. Coefficient, go and find out the maximum moment, maximum coefficient, sorry. And irrespective of plus minus, you can just choose maximum. So what will be the maximum coefficient? Point not 38. Okay. So we will get maximum coefficient as a 0.038, not. I need some space here again, so I will try to reduce the text height. Moment. Coefficient into WH cube. Can you calculate this for me? Meanwhile, I will try to. Point not 38 into WH means 41 into H square. WH, we have H cube, and WH means WH means 41. So into, you can just apply it two more times, right? 4.1 into, or maybe simply you can just write as a 10 into 4.1 cube. I will do like this. That will be very easy. Now, can you please calculate this?
Two 2.62.
How much?
2.62.
Correct. So let's say 3 kilonewton per meter.
Sir, while calculating moment, we don't have to consider the negative coefficient, right?
Yes. So actually you have to calculate both. But if you calculate the maximum, so it will take, what is the negative and positive? So negative means hogging and positive means sagging.
Sir, at 1H, it is minus 0.0146. So that will be maximum now if I don't consider positive or negative side.
No. Yes. So tell me. Uh, and at wall is fixed at the
Hmm.
base, correct? Wall is fixed
Yes,
at
sir.
the bed, means which type of movement will be generated at the base of the wall? Positive, negative, or forget about positive, negative, sagging or hogging? Which type of at wall?
It will be negative, sir.
Negative
Hogging.
means hogging, correct?
Yes.
It will be
Hmm.
negative, means.
Hmm.
So obviously what happened? So they are considering positive means hogging. Okay. So if you see 0, okay, 0.1 H, that is a top, something like that they are talking about. Oh,
Yeah.
I think we missed this. Point not 38, no, minus point not 146. So no one see this one, correct? So instead of point not 38, we need to consider this minus 0.416. Okay, so just go back and change this one. You ask a good question. I also not seen that. 0.146.
4.6.
146. So there will be change in our values. Values are irrespective, but I will explain you how it works.
Sir, it is coming 10.06.
10.06. Let's say 10 only. Okay,
Okay.
10. And it is given as a negative. Can you
Yes.
see this negative? Okay, means you are correct. You are saying hogging, negative movement. That's why it's negative. Okay. If you go to the 0.9, it is negative. If you go to the 0.8, it is positive. Then positive, 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 0. Okay, means if I try to draw the pattern of wall, so let's say, so this understanding of this pattern is very important. My mouse is not, I need to consider take some mouse pad. So suppose this is a wall, okay, subjected to the this triangular load. This is a free, okay, so obviously there will not be moment. Agree?
Yes, sir.
And at base it will be subjected to the negative moment.
Okay.
Okay,
Hmm.
so what will be the pattern? So I'm just trying to generalize things. Okay, this will be negative, this will be positive. Okay, so now we are getting this 10.06, something like that. So if you make 10 parts of this wall height and find out the, and if you try to find out the all the moments at the point like 0.9, 0.8, 0.7. So what happens if you draw based on that? What you will get? You will get some pattern. Okay. So because of this, what happened? The bending moment pattern will also get from positive to negative to positive. So that same repeats. So up to the point 1h negative, negative, 0.8 negative, 0.9 negative, and between 8 to 9 it will be changing. So ideally it will be something like that. So if I consider this 0.9 and this is 0.8, so this will be something like this. Okay, understand what I want to say?
Yes, sir.
No, sir.
Yes, sir.
किसको नहीं समझा मैं, I will try to explain again. क्या उसमें क्लियर नहीं है?
ये पॉजिटिव नेगेटिव का,
पॉजिटिव नेगेटिव का क्लियर नहीं है. ओके,
तो ये चीज सर टेंशन में भी अप्लाई होगा?
सब जगह पे टेंशन ही है, बस पॉजिटिव नेगेटिव है टेंशन. थोड़ा सा अच्छा स्केच निकालने की मैं कोशिश करता हूँ अविनाश जी. थोड़ी मुझे आप हेल्प कीजिए. ठीक है, ये मेरा पूरा हाइट है, ये मेरा 0.9h है, ये मेरा 0.8 है, ये मेरा 0.7 है. ठीक है, वो तो समझ में आया आपको अभी?
हाँ, ये समझ में आया सर.
हाँ, तो अभी हमने 1h पे कितना निकाला हमने?
सर 0.00 था.
हाँ, तो 10 अपनी वैल्यू कितनी आ गई? 10 किलो न्यूटन.
जी.
तो ये समवेयर यहाँ पे आ गई. तो अभी मुझे आप बोलिए 0.9h को कितनी आएगी? आपके सामने ये मेरा फॉर्मूला भी है.
वो तो कैलकुलेशन करना पड़ेगा.
हाँ करिए ना जरा, इसलिए मैंने आपको बोला कि आप मुझे जरा हेल्प कीजिए. 0.9h को मोमेंट कितनी आएगी?
सर ये एक चीज बताइए, ये एच हाइट है ना?
हाँ, h हाइट है. भक्ति जी आप भी एक बार आपने यहाँ पे कैलकुलेट कीजिए, सो वी कैन क्रॉस चेक दैट आंसर.
Yes, sir.
6.21.
Okay, let's check with Bhakti also.
Sir, it is 1.52 at 0.9h, na?
हाँ, at 0.9h.
1.52.
I will check. (1.52) आपका कुछ तो गलत हो रहा है अविनाश जी.
सर कोफिशिएंट मैंने लिया 0.002,
हाँ
डब्ल्यू मैंने लिया 41, एच लिया
नहीं,
मैंने।
W41 नहीं, W10 होगा, H क्यूब।
सर तो ये यूनिट वेट है।
हाँ, W आप वैसे भी कर सकते हैं। W आपने 41 का कैसे है, 41 कैसे है आपका?
तो सॉइल प्रेशर मैंने वहां से लिया था ना उसका।
नहीं नहीं नहीं, W41 कैसे आया? 10 इंटू हाइट है ना।
सर मैंने एच लिया 4.1, उसको क्यूब में मल्टीप्लाई कर दिया, 3 टाइम्स मल्टीप्लाई किया, फिर
6
एक
टाइम।
साथ सबको मल्टीप्लाई कर दिया। मैं बता रहा हूँ आपको।
हाँ नहीं, अप टू द W ओके करेक्ट है, लेकिन 41 कैसा है? 41 हमने कैसे निकाला? इसमें 4.10 वाटर का है इंटू ऑलरेडी हमने हाइट मल्टीप्लाई की है, तो यहाँ पे फॉर्मूला क्या दे रहा है? H क्यूब। तो आपको बाद में बस H स्क्वायर करना है ना, तो हम आपका क्या हो रहा है, एक 10 एक्स्ट्रा हो रहा है, 1 हाइट एक्स्ट्रा हो रही है।
अच्छा, मतलब डब्ल्यू एच का वैल्यू 41 है।
WH का वैल्यू 41 है, तो अभी आप इसको कैसे कन्वर्ट करेंगे?
तो फिर तो सर एच स्क्वायर बचेगा तो फिर मल्टीप्लाई हो
हाँ,
जाएगा।
करेक्ट करेक्ट। तो अब जरा फिर एक बार मुझे बताइए आपका कितना वैल्यू आ रहा है?
1.51।
करेक्ट निकाला है अभी आपने। हम्म। तो मुझे यहाँ पे प्लॉट करना है। अब ये 10 हो गया और ये 1.1, मतलब मैं ऑलमोस्ट मैं यहाँ पे, अगर मान लीजिए ये 0 है, हम्म, तो ये कहाँ पे होना चाहिए? समवेयर हियर।
लेकिन सर अगर उस तरह अगर दिया रहता डब्ल्यू एच का वैल्यू, लेकिन वहां पर एक साथ लिखा है डब्ल्यू इंटू एच क्यूब लिखा है सर, तो सिर्फ हम
हाँ
डब्ल्यू का वैल्यू इनपुट करके फिर एच का जो हाइट है उसे कर दें।
हाँ, कर दीजिए ना, उतना ही होगा ना।
तो फिर डब्ल्यू का वैल्यू हम लोग को 41 लेना है, या 10 यूनिट वेट है डब्ल्यू, या फिर वो सॉइल प्रेशर है, हमको ये बताइए।
यूनिट वेट है,
हाँ
10
ठीक है
होगा।
तब, हाँ तब ठीक है।
हाँ, तो अभी ये आपका आ गया 1.55। ठीक है, अभी एक काम काम कीजिए, और एक अभी पॉइंट H को निकालिए, कितना आता है?
0.88 सर।
0.8H के लिए
ये इसका 0.4146, सर 0.41146।
आप मुझे आंसर बताइए ना कितना आ रहा है। भक्ति जी, आप भी चेक कीजिए।
किसका सर?
.8H, अभी आपने 0.9H का निकाला ना,
हाँ 0.8, ओके।
वैसे अभी 0.8 का H का निकालिए। चेक करते हैं।
1.99।
करेक्ट, आप एकदम करेक्ट निकाला है आपने। अभी ये क्या है? ये पॉजिटिव है ना,
यस सर।
पहले वाले दो निगेटिव थे।
हाँ
तो अभी हमको यहाँ पे जाना पड़ेगा, अगर ये हमने निगेटिव माना तो यहाँ पे पॉजिटिव होना चाहिए ना, ये इस
बिल्कुल।
बार के बाजू में।
यस सर।
हाँ, तो हम क्या करेंगे, 1.2 मतलब 2 पकड़ो। हम्म,
ओके।
तो ये मैंने 2 पकड़ा,
यस सर।
तो ये ऐसा कुछ तो ये पॉइंट, या सॉरी, मैंने यहाँ पे पकड़ना चाहिए, क्योंकि ये 0.9 है, ये 0.9 है, तो हाँ ये यहाँ पे होना चाहिए, ये इधर। तो अगर मैं इसको जोड़ू तो ऐसे कैसे तो होना चाहिए ना।
बिल्कुल।
तो हो गया है ना, पॉजिटिव का माइनस निगेटिव, निगेटिव से माइनस पॉजिटिव।
हाँ
समझ में आया अभी कैसे हो रहा
हाँ,
है, क्यों
ये
हो
तो
रहा है?
ठीक, लेकिन सर जब वो हैगिंग और हॉगिंग एंड सैगिंग का आप जो बता रहे थे उस समय कि 0.146 लेंगे, शुरू
हम्म,
में टेंशन में हम लोग पॉजिटिव वैल्यू लेके चल रहे थे, तो
नहीं
एक
ये सब
मोमेंट।
टेंशन ही है, ये पहली बात है, ये सब हम टेंशन ही है, ये कॉम्प्रेशन नहीं है, बस निगेटिव को हम हॉगिंग बोल रहे हैं, और पॉजिटिव को है उसको हम सैगिंग बोल रहे हैं।
ओके।
ये पूरा टेंशन ही है, यहाँ पे कॉम्प्रेशन बिल्कुल भी नहीं है। अगर कॉम्प्रेशन होता तो हम निकालते ही नहीं है।
नहीं, मैं
ठीक है।
कंप्रेशन नहीं बोल रहा हूँ सर, वो
हाँ
मोमेंट में हम लोग बोल रहे हैं कि टेंशन में हम लोग, आपने भी थोड़ा पहले बोला पॉजिटिव वैल्यू लेना है, ठीक है?
नहीं
हम
नहीं,
लोग
हाँ लेकिन मैक्सिमम लेना है ऐसा मैंने बोला था।
हाँ,
मैंने
मैक्सिमम लेना
हाँ पॉजिटिव मैंने कब बोला, टेंशन के लिए बोला। टेंशन हम, लेकिन हम यहाँ पे क्या कर रहे हैं, बेंडिंग मोमेंट निकाल रहे हैं ना।
हाँ, बेंडिंग मोमेंट निकाल रहा है।
हाँ तो बेंडिंग मोमेंट में दोनों भी लेना पड़ेगा, करेक्ट।
पॉजिटिव
मैक्सिमम
नेगेटिव दोनों लेना पड़ेगा।
हाँ लेना पड़ेगा। लेकिन उसका एक सॉल्यूशन भी मैंने बोला कि अगर आपको एक ही झटके में सब करना है तो मैक्सिमम ले लो, रिस्पेक्टिव ऑफ ये पॉजिटिव नेगेटिव। तो क्या हो रहा है, ये हो रहा है। तो 0.146 के इसके अगर हम, आपने अगर ये लिया तो बाकी को आपको लेने की जरूरत नहीं है। अगर आपने इसको डिजाइन किया, मतलब अपना कितना आ रहा है 10 किलो न्यूटन, अगर इसने आपको, आपने इसको रेनफोर्समेंट डाल दिया तो बाकी जगह पे ये सब सेफ हो रहा है। ठीक है,
ओके सर।
ये मेरा कहने का मतलब था।
ओके सर।
ठीक है, तो इस जगह, इस on same basis now we can calculate the bending moment। ऑलरेडी हमने कैलकुलेट किया। अभी क्या बचा है, कितना आया था, 10 किलो न्यूटन। अभी एक बचा है शेयर फोर्स F। तो सेम थिंग है, अगर आप सॉइल पे ले जाओगे तो सॉइल के लिए भी बस यही फॉर्मूला रहेगा। आपको 2 बार करना पड़ेगा, एक ट्रायंगुलर एंड एक सरचार्ज। सेम थिंग, जस्ट क्लियरिकल वर्क, just we need to find out the coefficient, but otherwise everything will be same। now we will calculate the shear force। तो shear force के लिए ये क्या बोल रहा है, go to that table, shear force table A12, table A12। so just go through this। V means shear force। how to calculate the shear force coefficient into, there are 3 formulas। first, coefficient into WH square, that is for the triangular pressure। if you have rectangular pressure, then coefficient into pH, okay। and if it is subjected to the moment at base, so which is rarely we use, then coefficient into moment divided by h, okay। so now this case we don't exist, okay, last moment। so maybe we need to calculate for this triangular and rectangular। so same thing, wh square by dt 8, triangular, agar you can see this triangular load fixed base, so we will get directly coefficient 0.70174। so calculate करो कितना होता है। shear force formula is in front of you। coefficient in, that is coefficient means 0.174 into WH। W means 10, H means 4.1 square। how many, कितना है shear force due to the water pressure?
29.24।
correct। so let's assume
सर एक चीज और था, यहाँ कोफिशिएंट में आपने जो यहाँ डब्ल्यू लिया 41, तो यहाँ भी तो 10 ही हो जाएगा ना?
हाँ 10 ही होगा, अगर वाटर है तो 10 ही हो जाएगा।
ओके।
अगर आपके पास दूसरा कुछ लिक्विड है और
हम्म।
उसकी डेंसिटी आपको मालूम है तो वो आप चेंज कर सकते हैं।
ओके।
ठीक है, अभी हम रेक्टेंगुलर के लिए भी निकालते हैं। तो अपना सरचार्ज कितना आया था, सॉइल सरचार्ज 10 है, और वाटर प्रेशर भी, सॉइल प्रेशर भी सेम आया था। दिस इज फॉर वाटर, this is for soil, that will be also same since the intensity is same। plus we need to consider additional surcharge 30 किलो न्यूटन प्लस। भी आप मुझे बताइए फॉर सरचार्ज कितना होगा, रेक्टेंगुलर लोड एंड आवर वैल्यू इज, सरचार्ज की कितनी वैल्यू है सॉइल 1 मीटर 10 किलो
10।
न्यूटन। तो ये आप मुझे बताइए, ये फॉर्मूला है, देखिए पी एच, पी मीन्स दैट 10, वो कितना होगा?
P means sir?
P means surcharge value, pressure.
One 1.93.
नहीं, गलत आ रहा है।
The P into H.
कोएफिशिएंट आपने क्या लिया?
0.193.
0.193 इंटू P मीन्स अपना कितना आ रहा है? 10
10.
इंटू 4.1,
Oh, M 4.1 छूट गया, सॉरी.
तो कितना हो गया? राउंड फिगर करके 8 हो गया। ठीक है,
7.918 हो गया सर.
ये 8 पकड़िए। सो टोटल शेयर फोर्स ड्यू टू द सॉइल प्रेशर विच विल बी 38 किलो न्यूटन। डन।
यस सर.
तो हमने अभी सर्कुलर टैंक के लिए क्या क्या निकाला? टेंशन निकाला, मोमेंट निकाली, वाटर के लिए शेयर फोर्स निकाला, और सॉइल फोर्स के लिए, सॉइल प्रेशर के लिए we have calculated the shear force. So all we get all the required inputs to design the reinforcement. Same thing if you want to design the base slab, whatever reinforcement that you will be get for the wall, same reinforcement can you provide to the base slab. Simple, done. So this way, can you use the PCA table for analysis purpose for the circular tank? सिंपल है ना काफी?
Yes, sir.
इज इट ओके?
यस सर.
नाउ अभी अविनाश जी, अभी हम क्या करेंगे नेक्स्ट सेशन में? वी विल स्टार्ट विद द सॉफ्टवेयर। तो मैं आपको अभी दिखाऊंगा कि रेक्टेंगुलर टैंक का कैसे करते हैं, क्या करते हैं। ठीक है
सर. ओके सर. सर इसमें एलिवेटेड वाटर टैंक भी डिजाइन कीजिएगा.
हाँ, है ना, वो भी आप अपना शोले वाला, गब्बर सिंह वाला वो भी है टैंक।
ओके सर.
तो बिफोर स्टॉप टुडे, इज देयर एनी क्वेश्चंस?
सर वो शेयर फॉर सॉइल्स 30+8,
हम्म।
तो 30 एडिशन क्यों हो गए सर?
हाँ, 30 एडिशनल क्यों हो गया? क्योंकि 10, ये 8 तो आपको पता चला
यस
सरचार्ज। अभी
सर.
शेयर सॉइल प्रेशर कितना है?
41.
41 है ना? तो 41 और वाटर प्रेशर भी 41 है, तो हमने ऑलरेडी ये कैलकुलेट किया था 30। तो दैट्स व्हाई आई जस्ट टेक इट एज ए 30, क्योंकि वो
ओहो.
सेम है। बाय
सेम.
बाय मतलब क्या, कोइंसिडेंस, अपने
यस.
वाटर प्रेशर और सॉइल प्रेशर सेम आ गए, इसलिए मैंने वो 30 डायरेक्टली कॉपी किया है। अगर ये 42 और 52 होता तो आई विल नीड टू कैलकुलेट दिस।
यस यस यस. और जो शेयर टेंशन हुक टेंशन जो निकाला था सर, उसमें 1.4 क्यों मल्टीप्लाई हुआ था सर?
हमने लोड कॉम्बिनेशन कंसिडर किए, क्योंकि मान लो फैक्टर्ड लोड 1.5 1.4 जो भी है, मैंने वो बस एज्यूम किया।
Okay,
तो दैट्स व्हाई, सो आई एम एज्यूमिंग फैक्टर एज अ 1.4. So maybe
Okay.
based on your load combination, you can consider 1.2, 1.5, whatever जो भी IS कोड अगर आए,
Yes,
हाँ
yes.
यूज करने वाले तो यूज करो।
ठीक सर, ठीक सर. Perfect sir. Thank you sir.
Any another thing, questions? Did you find the PCA table from the internet?
यस सर.
इफ नहीं, अगर आपके पास नहीं है तो आप मैडम को मांग सकते हैं, ये क्लास के वो प्रज्ञा मैडम है ना, so आप maybe you can check with her, so maybe she can give you. If you not, then let me know, so maybe during next session I will check with I think प्रज्ञा ना, मैडम का नाम मैं भूल गया अभी।
प्रज्ञा नाम है.
प्रज्ञा, हाँ हाँ हाँ, तो मे बी आप यू कैन जस्ट चेक विथ हर, सो वो आपको दे सकते हैं, शेयर कर सकते हैं पीसीए टेबल्स।
ओके.
ओके, ऑल गुड?
यस सर.
सो डिड यू फाइंड दिस वेरी इजी फॉर एनालिसिस, सर्कुलर एंड वाटर टैंक, रेक्टेंगुलर टैंक्स?
Yes, sir.
ओके, यस। सो मे बी अभी हमारा सेशन फ्राइडे है, बट आई विल ट्राई टू कंडक्ट ऑन थर्सडे, but definitely well in advance I will let you know. अगर
sir.
थर्सडे को पॉसिबल होता है तो
ओके
ठीक
सर
ठीक है. Okay then, bye for now, and we will meet again in next session. Okay, thank you.
Thank you, son.
Thank
Good
you.
night.
गुड नाइट सर